Welcome to lesson 11B, a little bit more advanced work. At this point, we're going to turn repeating decimals into fractions, but all of the decimal portion is not repeating. So now we cannot use the shortcut. We must use this process to figure it out. So it is not the shortcut. Not all of this 4-3 is going to be on the numerator. It's going to be a little bit different this time. We're going to follow the same process. So let's try it. So we're going to rewrite the decimal as 0 point something it already is. We'll learn some more processes when it's not there. We're going to set up our equation. X equals 0.43, and then repeat our repeat. What's our repeat? It's just the 3, not the 4-3, just the 3. And we're going to just repeat it once. Now we're going to move that decimal to after the repeat. So the decimal started out before the 4, but the repeat was actually the 3. So the decimal needs to move to after the 3. It goes here. So how many places did we actually move the decimal? We actually moved it 2 places. That's 10 to the power of 2. That's 100. So in order to keep our equations equivalent, or both sides of the equation equivalent, make a new equivalent equation, we need to multiply both sides by 100. So 100 times x is 100x. And what does the right side of the equation equal? Well, we can see here by moving that decimal, it's now 43.3 repeating. Okay, let's go ahead and move to step number 3. Okay, our next step is to move the decimal to before. Remember, when we did these on the easier steps, the decimal was already before the repeat. This time it is not. It's not directly before. So we actually have to move the decimal this time to before the repeat. Well, how many times did we move it this time? We moved it once. So that's 10 to the power of 1. That's just 10. So now this time we're going to multiply both sides of our equation, our original equation, by 10. So 10 times x is 10x. Notice I'm still lining everything up. I'm doing everything exactly the same. And when I moved the decimal this time, it was here. Now it's here. And I have 4.3 repeating. Again, I can kind of ignore that extra part because I only need one place after the decimal to line up with the decimal above it, or the equation above it, sorry. 4.3 repeating. And now I'm on to step number 4, subtract my equations. 100x minus 10x. Well, 100 minus 10 is simply 90. I'm not really doing the steps here to subtract. I'm using number sense. 100 minus 10. 0 minus 0 is 0. 10 minus 1 is 9. Okay, now, did the same or the proper thing happen here? My decimals lined up. Did I have the repeating portion of my decimal line up, and is it the exact same? Yes, it is, and therefore, 3 repeating is, minus 3 repeating is nothing. There we go. Okay, 43 minus 4. Now here we go, ladies and gentlemen. This is subtraction, right? We're subtracting these two things. Make sure you subtract properly. At this point, I would be okay if you used a calculator to check your work, but please make sure you're doing this work correctly. There are times when I'm going to ask you to be able to do elementary math without a calculator, so make sure you know how to do it. 13 minus 4 is 9. 3 minus nothing is 3. Okay, we're now to solving for x and simplifying. At this point, we know we're going to solve both sides by the coefficient of x. Divide. The 90s cancel. X is equal to 39 over 90, which means that 0.4 with just the 3 repeating is actually 39 over 90. Now, wait a minute. Remember, there's this part that says simplify. So we haven't really talked much about that, but we want a simplified fraction. And this fraction I know is actually not simplified, and I know that through my divisibility rules. 3 plus 9 is 12. 9 plus 0 is 9. 12 and 9 are both multiples of 3. Also, I can just look at these digits. 3, 9, and 9 all are divisible by 3. So I know I can actually divide this by 3 and this by 3. And I'm not going to do long division here. I'm just going to use some mental math because every single digit is divisible by 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. See, there's nothing left over when every single digit is divisible by 3. 9 divided by 3 down on the bottom here is 3, and 0 divided by 3 is 0. So 0.43 repeating is the same thing as 39 over 90 or 13 over 30. Hey, we just finished. Let's try another example. one that's similar, 0.25 repeating. Let's see if we can rock and roll on this one. Set up that equation. It is already 0 point in the 0 point format. So x equals 0.25 with the 5 repeating. Let's repeat the repeat. There we go. We're going to move that decimal to after. Well, the repeat started with the 5, so we need to actually move it to after the first 5. How many times did we move that? We moved it twice. That was 10 to the power of 2. So I need to multiply both sides by 100. What did my number become? Well, moving the decimal here, it's 25.5 repeating. Okay, let's move it again. I'm going to move the decimal to before the repeat. There we go. How many times did I have to move it this time? 10 to the first power. So 10 to the first power is 10. Multiply both sides by 10. 10x equals, decimal now there, it's 2.55, but I only have to write one place because this first equation only has one place written. So now I have 100x minus 10x. Well, 100 minus 10 is just 90. X equals, and the decimals lined up. 5 repeating minus 5 repeating cancels. 25 minus 2, 23. Solve for x. Divide both sides by 90. The 90s cancel. X equals 23 over 90. So 0.2 with the 5 repeating. Notice the numerator is not 25 like our shortcut. It's 23. It's something different. And the denominator is not 99 like our shortcut. It's 90. Again, something different. It has the 9 in it. That's always going to be the case. But it's not the shortcut. Hey, can 23 over 90 be simplified? No, it cannot. 23 is a prime number and not a factor of 90. Okay, let's try a different example. How about this one? 3 digits after, but only the 9 and the 2. Only the last 2 digits are repeating. Okay, same process. Set up our equation. We already start with 0. X equals 0.792. That's the part repeating. Let's repeat it again. 92. I did the repeat over both just so you could see where it stopped and started. Don't have to do that if you don't want to. Okay, I'm going to move that decimal to after the repeat. Well, golly gee, how many times did we move the decimal this time? We moved it 3 times. That's 10 to the power of 3. Well, what is 10 to the power of 3? It's 1,000. If you're not sure what that number is, simply write a 1 followed by 3 zeros. There you go. It's 1,000. 1,000x equals, because 1,000 times x is 1,000x. And here we moved it 3 times. So we can put our pencil here and see what number do we have now. We can ignore the 0 point, and we have 792.92 repeating. 792.92 repeating. We're ready for our second equation. To subtract, we're going to move that decimal to before the repeat. Well, here, since I drew these repeat lines, you can really see where the repeat started, and it started right here. So how many times did I move it there? I only moved it 1 place. So again, 10 to the power of 1 is just 10. And 10 to the power of 1, putting in my decimal here, 7.92 repeating. Again, make sure you line up your decimals. And when you get ready to subtract, the numbers are all lined up. We're going to subtract. Now, what's 1,000x minus 10? So not 100x, it's 1,000x minus 10. Hey, this is 0 minus 0. And this is 100 minus 1. 100 minus 1 is just 99. That's 990x equals. Again, I used number sense to figure that out, not bigger, bottom, borrow. Okay, here we have the decimals lining up, 92 repeating minus 92 repeating. Yay, that's what needed to happen. Those cancel each other out. And now I just need to subtract. Okay, here I am using bigger, bottom, borrow. Again, we want to use some good math here. 12 minus 7 would be 5, 8 minus nothing, and 7. Okay, good. We're going to divide both sides by 990, the coefficient of x. Those cancel. X is equal to 785. Oops, sorry, my marker drug a little. It's a little harder to write down on the bottom of the board. And so 0.792 repeating is actually equal to 785 over 990. Now, can that be simplified? Yes, it can. How do I know? The numbers end in 5 and 0, and numbers ending in 5 and 0 can both be divided by 5. So I actually need to do some more work to do this actual step here, which says simplify. How am I going to do that? Hey, I'm going to come over to another part of my paper and do 785 divided by 5 and 990 divided by 5. So 785 divided by 5. 5 goes into 7 once. Subtract. I hope you're doing this along with me. 28, 5 goes into 28 5 times. 5 times 5 is 25. Subtract. 28 minus 5 is 3. Bring down. 5 goes into 35, 7. Hey, I'm done. 7 times 5 is 35. That's it. That's all I write. So 785 divided by 5 is 157. Okay, 990 divided by 5. 5 goes into 9 once. Multiply, subtract, and bring down. 5 goes into 49 9 times. 9 times 5 is 45. Subtract, bring down. 5 goes into 40. Hey, knowing your math facts really makes this process pretty easy. 8 times 5 is 40. And so I'm done. I ran out of numbers, and it worked out evenly. 198 is my denominator. Oh, yucky. That looks ugly. Let's fix that. Kind of look like a Google G or something. How about 198? Does that look better? Okay, now I'm going to decide, can this actually be reduced any further? Well, I'm going to use some of my divisibility rules. Their top one is not even, so it cannot be divided by 2. If I add the digits, 1 plus 5 plus 7, well, that's 7 plus 5 is 12, plus 1 is 13. So no, it has to be a multiple of 3. 3, 6, 9, 12. 13 is not. So all even numbers are out. Since it's not even, I can look, it's not 5 because it would have to end in 5 and 0. There's some other rules, but I'm going to tell you this is definitely simplified as far as it can go. I'm going to expect you here in 8th grade to look for the obvious rules to make sure that these are simplified as far as they can go. All right, let's go ahead and stop here for this example. And I have one more video when this first number is actually not 0. So excellent job with your second video. Good job.